Hey everyone, welcome back to Beyond Code. It's so good to see you here again. Today's video is a special one. It's not just about writing better code, it's about preparing for what's coming next. Believe it or not, 2026 is closer than it feels, and the tech world is changing faster than ever. AI is rewriting how we work, companies are hiring differently, and the skills that used to make you valuable might not be enough anymore. So, in this video, we're going to look ahead. We'll explore the 7 tech skills that will define the next few years, the ones that will keep you in high demand and get you paid what you're truly worth. If you're ready to grow, not just as a developer but as a creator, then this one's for you. Let's get started. Technology is evolving faster than ever, but here is a truth most people ignore. The world doesn't reward those who know the most. It rewards those who adapt the fastest. We live in an era where every 6 months, the rules of tech change. AI tools appear overnight. Frameworks become obsolete before you even master them. And while millions are waiting for the next big thing, a smaller group, the ones learning right now, are quietly building the foundation of 2026. If you want a high-paying tech career, if you want to be part of the future, this video will show you the 7 skills that matter most. Skills that companies are already searching for. Skills that can change your career, your income, and even the way you think. This isn't theory. It's the roadmap for the next decade of opportunity. So grab your focus, because in the next few minutes, you're going to see exactly what to learn, why it matters, and how to start today. Let's begin. Number 7, full stack development, the foundation of the future. Full stack isn't just about learning both sides of development. It is about seeing the entire system, from the first pixel a user touches to the last line of code on the server. In 2026, companies won't pay for specialists who only see half the picture. They'll pay for people who can connect everything, from database design to user experience. That's what full stack is, the art of building something complete. The market is changing. Startups want speed, corporations want versatility, and full stack developers deliver both. Why does it matter? The world is moving towards smaller, smarter teams. AI tools like Cursor, Windsurf, and GitHub Copilot are making individual developers incredibly productive. One skilled full-stack engineer can now do the work of an entire team if they know how to think strategically. The future doesn't belong to the one who codes the fastest. It belongs to the one who understands how the whole system breathes. Knowing React or Python is the starting line. What makes you indispensable is thinking like an engineer, understanding the why behind every feature, designing systems that scale, and solving performance problems before they appear. If you're starting today, here's your roadmap. Begin with HTML, CSS, and JavaScript. They're still the DNA of the web. Move on to React or Angular for the front end, and Node, JS or Python with Fast API for the back end. Learn PostgreSQL or MongoDB for data, and deploy on AWS or Vercel. Then build your first real product, even a simple one, because the best portfolio isn't a resume, it's a product that works. Number 6, advanced AI and machine learning engineering. This isn't just about using ChatGPT, it's about building the systems that power it. In 2026, the demand won't be for AI users, it'll be for AI architects. Companies need engineers who can fine-tune large language models, build custom neural networks, and integrate AI into their core products. This means understanding frameworks like TensorFlow and PyTorch, but more importantly, it means understanding the principles of data science. You need to know how to clean data, select the right model for the job, and deploy it efficiently. AI is no longer a niche field. It's becoming the engine of every industry, from finance to healthcare. Start by mastering Python and its data science libraries like Pandas and NumPy, then dive into a machine learning course. The real value isn't just training a model, it's understanding the data that feeds it and the business problem it solves. Coming in at number 5, cybersecurity and data privacy. As our world becomes more connected, it also becomes more vulnerable. Every new device, every new app, is a potential entry point for a threat. By 2026, cybersecurity won't be a department, it will be a mindset embedded in every team. The demand is shifting from reactive fix-it roles to proactive prevent-it roles. We're talking about ethical hackers, cloud security architects, and privacy engineers who design systems that are secure by default. The key here is to think like an attacker, understand network protocols, encryption, and common vulnerabilities. Learn tools like Wireshark and Metasploit, but also learn the law. Regulations like GDPR and CCPA are shaping how companies handle data, making privacy engineering one of the fastest-growing fields. A career in cybersecurity isn't just about protecting code, it's about protecting people. At number 4, we have cloud engineering and DevOps. The cloud isn't just someone else's computer anymore, it's the operating system for modern business. Companies are no longer asking if they should move to the cloud, but how fast they can get there. Cloud engineers who can design, build, and maintain scalable infrastructure on platforms like AWS, Azure, or Google Cloud are indispensable. But it's not just about spinning up servers. The real magic is in DevOps, the culture and practice of automating everything. This means mastering infrastructure as code with tools like Terraform and building CI/CD pipelines with Jenkins or GitLab. The goal is to make deploying software as boring and reliable as flipping a switch. In 2026, a developer who understands cloud and DevOps is 10 times more valuable because they don't just write code, they deliver it, securely and at scale. Number 3 is a big one, product management with a technical lens. In the age of AI, the most valuable products won't be built by engineers alone. They'll be guided by product managers who deeply understand technology. A great product manager in 2026 won't just write user stories. They'll be able to discuss API design with engineers, understand the trade-offs of different machine learning models, and grasp the complexities of a cloud architecture. This isn't about knowing how to code, but about knowing what is possible with code. They are the translators between the business goals and the technical reality. They ask the right questions, prioritize the features that deliver real value, and guide the team through ambiguity. If you love technology but are also passionate about strategy and user psychology, this is your path. Learn the fundamentals of agile development, user research, and market analysis, but never stop learning about the tech itself. Our runner-up at number 2, data engineering and scalable systems. If data is the new oil, then data engineers are the ones building the refineries. We generate an incredible amount of data every second, but it's useless until it's collected, cleaned, and made available for analysis. This is the work of a data engineer. They build the pipelines that move data from hundreds of sources into a central data warehouse or lake. They design systems that can handle petabytes of information without breaking a sweat. In 2026, with AI and analytics at the core of every business decision, the demand for skilled data engineers will explode. This means mastering tools like Apache Spark, Kafka, and data warehousing solutions like Snowflake or BigQuery. The key skill is designing for scale. It's one thing to process a gigabyte of data. It's another to build a system that can handle 1,000 times that reliably, every single day. Number 6, cloud computing and DevOps, the invisible infrastructure. Think about this for a second. Every modern company you interact with lives in the cloud. That streaming service you binge-watched last night, your banking app, even your favorite online games, they all run on massive distributed virtual infrastructure. But here's the twist that most people miss. The real magic of the cloud isn't just about storing your photos or files, it's about automation, reliability, and speed. In the next couple of years, companies will be willing to pay more than ever before for developers who truly understand how to build, scale, and maintain systems safely and efficiently. Imagine you're an architect, but instead of designing physical buildings, you're creating invisible ones. You design how servers communicate with each other, how they automatically scale up to handle millions of users, and how they recover instantly when something inevitably goes wrong. You are building the digital foundation of the modern world. So what do you actually need to learn to become one of these digital architects? First, get comfortable with the fundamentals of Linux. It's the bedrock of almost everything in the cloud. It's your foundation. Don't skip it. Next, you need to learn Docker. Docker allows you to package your applications into these neat little boxes called containers. This makes them portable, consistent, and easy to manage, no matter where they run. Think of it like putting your application and everything it needs to run into a standardized shipping container. You can ship it anywhere, and it will just work. Once you've mastered containers, it's time to study Kubernetes. If Docker is the shipping container, Kubernetes is the global logistics system that manages millions of those containers across a fleet of ships. It's the language of large-scale infrastructure, orchestrating how your applications are deployed, scaled, and managed automatically. It's complex, but it's the standard for a reason. Then, you need to understand CI/CD pipelines. CI/CD stands for Continuous Integration and Continuous Deployment. This is the automated assembly line for your software. Using tools like GitHub Actions, Jenkins, or GitLab, you can set up a process where your code is automatically tested, built, and deployed to users with just a single push to your repository. This is how modern companies release new features multiple times a day, not once every few months. And finally, you can't manage what you can't see. You have to learn how to monitor and secure everything. Tools like Prometheus and Grafana help you create beautiful dashboards that show you the health of your systems in real time. You can see CPU usage, memory, network traffic, everything. And on the cloud provider side, services like AWS CloudWatch give you deep insights into your infrastructure's performance and security. The moment you can confidently deploy an application, scale it to handle a surge in traffic, and have it automatically recover from a failure all by yourself, you're no longer just a developer. You've become a systems engineer. You are someone who can run a digital empire from a laptop. But let's pause for a moment, because here's the deeper truth. DevOps isn't just about learning a bunch of tools. The tools will change. What won't change is the philosophy behind it. DevOps is a mindset. It's a culture of collaboration between development and operations. It's the belief that says, I won't just build this thing once. I'll make it faster, more reliable, and more secure every single day. It's about continuous improvement. That's why companies are so desperate for great DevOps engineers. It's not just because they know Kubernetes or AWS. It's because they think like owners, not just employees. They take responsibility for the entire lifecycle of a product, from the first line of code to the experience of the end user. They are the ones who ensure the invisible infrastructure that powers our world remains strong, resilient, and always available. And that is a skill that will only become more valuable over time. Subscribe and hit that notification bell so you don't miss the next part of our series. See you in the next one. 5. Cybersecurity, the digital war. The future is digital, and so are the wars we fight. Every single click, every transaction, every line of code is a potential battlefield, a potential attack vector. In this new world, cybersecurity isn't a luxury anymore. It's a fundamental requirement for survival. Think about it. We live our lives online, we run our businesses online, our entire global infrastructure is connected. And in this interconnected world, data is the new gold, and hackers, they're the new thieves, constantly on the prowl. Since 2022, the number of global cyber attacks has tripled, and that number is still climbing at an alarming rate. It's not just the big corporations making headlines. Every company, every organization, even the small ones, are targets. A single weak password, one misconfigured server, or a simple phishing email can bring an entire business to its knees. This is why cybersecurity professionals are not just in demand. They are some of the highest paid, most critical experts in the entire tech industry right now. They are the digital guardians of our modern world. So, what exactly does a cybersecurity professional do? It's more than just sitting in a dark room with glowing monitors. They are digital strategists. They have to think like the attackers, anticipate their moves, and build defenses to counter them. They're like detectives, hunting for vulnerabilities and weaknesses in a system before the bad guys can find and exploit them. They build digital fortresses, and then they try to break them down themselves just to make sure they're strong enough. It's a constant cat-and-mouse game, a high-stakes chess match where the board is the entire internet. This field combines the thrill of a puzzle with the responsibility of protecting people, data, and livelihoods. If you're intrigued by this and want to start a career in cybersecurity, where do you begin? It might seem overwhelming, but you can build a solid foundation step by step. First, learn the basics of networking. You need to understand how computers and systems communicate with each other. Think of it as learning the language of the internet. Without this, you can't understand how attacks happen or how to stop them. Next, dive deep into operating systems. Focus on the big ones, like Windows and Linux. You need to understand their internals, how they manage processes, memory, and permissions. Knowing the OS inside and out is like knowing the layout of a building you're trying to defend. You need to know every door, every window, and every hidden passage. This knowledge is crucial for identifying vulnerabilities and securing the system from the ground up. Once you have that foundation, it's time to explore the exciting world of ethical hacking. This is where you learn to use the same tools and techniques as the attackers, but for a good cause. Get familiar with powerful tools like Metasploit for exploitation and Burp Suite for web application testing. By learning how to attack a system, you'll gain invaluable insight into how to defend it. Ethical hacking is about being proactive, not reactive. It's about finding the holes before they can be used against you. Of course, you can't just be an attacker. You also need to be a defender. This means understanding the core principles of defense, encryption, authentication, and incident response. Encryption protects data by scrambling it, making it unreadable to unauthorized eyes. Authentication ensures that only the right people have access. And incident response is the playbook for what to do when an attack does happen. How do you contain the damage, eradicate the threat, and recover? A good incident response plan can be the difference between a minor hiccup and a catastrophic failure. As you gain more knowledge and practical experience, it's a great idea to validate your skills with respected industry certifications. For beginners, something like the CompTIA Security Plus is a fantastic starting point. It covers a broad range of fundamental security concepts. As you advance, you might pursue certifications like the Certified Ethical Hacker, or CEH, to specialize in offensive security. And for those aiming for leadership roles, the CISSP, or Certified Information Systems Security Professional, is considered the gold standard. These certifications not only prove your expertise to employers, but also provide a structured path for your learning and professional growth. But remember, the real skill in cybersecurity isn't just about knowing the tools or collecting certifications. The true art lies in anticipation. It's the ability to see the attack before it happens, to connect the dots that others miss, and to think several moves ahead of your adversary. It's a mindset, a way of looking at the world with a healthy dose of skepticism and a relentless desire to protect. The world doesn't just need more people who can write code. It needs people who can protect it. It needs guardians for our digital future. Trust is the currency of this new era, and you can be one of the people who helps build and defend it. 4. Artificial intelligence and machine learning, the core of transformation. AI is no longer just something you see in sci-fi movies. It's already part of your everyday life, from the camera on your phone to the shows Netflix recommends for you. But as we look towards the future, AI isn't just a handy tool. It's becoming a fundamental language, and the people who can speak it will be the leaders of the next decade. So, what does this actually mean for you? It means taking the time to understand how artificial intelligence learns, how vast amounts of data are transformed into accurate predictions, how machines are being taught to see, hear, and even make decisions. Now, I know what you might be thinking, and the key insight here is that you don't need a PhD in computer science to get started. All you truly need is a sense of curiosity and a clear, structured path to follow. So, where do you begin this journey? Let's break it down. First, start by learning Python. It's widely considered the native language of AI development, making it the perfect foundation. Next, you'll want to brush up on some core mathematical concepts, specifically linear algebra and statistics. Don't let the math scare you. These are simply the principles that make the magic happen. Think of them as the grammar of AI. Once you have those basics down, it's time to get your hands dirty. Start playing with popular libraries like scikit-learn and TensorFlow. These tools will allow you to train your very first simple models. From there, you can dive deeper into the world of deep learning with a framework like PyTorch, which is a favorite among researchers and developers for its flexibility. A great way to practice is by experimenting with real-world datasets. Websites like Kaggle are fantastic resources where you can find data on almost anything and see how others are solving complex problems. After you've grasped the fundamentals, you can start exploring more specialized fields. If you're fascinated by how machines interpret images, you could look into computer vision. This is the technology behind facial recognition and self-driving cars. If you're more interested in language, then natural language processing, or NLP, is the field for you. It's what powers virtual assistants like Siri and Google Translate. And if you dream of building intelligent robots or automated systems, then reinforcement learning is the path to explore. But here is the most important truth about all of this. AI is not here to replace you. It's here to amplify you. It's a tool that can extend your capabilities far beyond what was previously possible. The people who learn how to train AI models will be the ones creating the next generation of incredible tools. And the people who understand how to apply AI wisely will be the ones who revolutionize entire industries, from healthcare to finance to art. Here's a pro tip for anyone just starting out. Begin building small, manageable AI projects right away. Don't just watch tutorials. Apply what you learn. You could create a simple sentiment analyzer that tells you if a tweet is positive or negative, or maybe a basic face recognition app for your photos. You could even build a simple AI that helps you write emails. Each project you complete, no matter how small, will teach you more than watching 10 hours of tutorials ever could. It's in the act of building that the real learning happens. Artificial intelligence is the engine driving what many call the fourth industrial revolution. It's changing the world at an unprecedented speed. And in this new era, you really have two choices. You can either learn to use this powerful technology, or you risk being left behind by someone who does. The future is being built with code and data, and you have the opportunity to be one of its architects. 3. Data and analytics, the new oil of the 21st century. Have you ever heard the saying, data is the new oil? It sounds a bit dramatic, right? But honestly, it's more true today than ever before. Think about it. Our entire world, from the apps on our phones to the decisions made by the biggest companies, runs on data. It's what fuels every algorithm, every business strategy, every single line of code. But here's the catch. Raw data, just like crude oil, isn't very useful on its own. It's just a massive, messy collection of numbers and text. It needs to be refined. And that's where data analytics comes in. It's the refinery of our digital age. It's the process of taking all that raw, messy information and turning it into something clean, understandable, and incredibly valuable. Insights. From marketing and finance to healthcare and entertainment, every single industry is desperate for people who can do this. They need experts who can look at a sea of data and find the hidden patterns, the trends, the stories that lead to smarter decisions. If you can develop that skill, you don't just become valuable, you become indispensable. So, how do you get started on this path? It's more accessible than you might think. Let's break it down into a clear roadmap. First, start with the fundamentals. And I mean the real basics. Learn Excel and Google Sheets inside and out. These tools are the Swiss Army knives of data. Mastering things like pivot tables, VLOOKUPs, and conditional formatting will teach you the core principles of organizing and manipulating data. Don't skip this step. It's the foundation for everything else. Once you're comfortable with spreadsheets, it's time to level up to SQL, which stands for Structured Query Language. This is the language you use to talk to databases. Almost every company stores its data in databases, and SQL is how you ask questions and pull out the specific information you need. Learning SQL is non-negotiable for anyone serious about a career in data. Next up, it's time to embrace the power of programming with Python. Now, don't be intimidated. Python is known for being beginner-friendly. For data analysis, you'll want to focus on specific libraries that make the work so much easier. The two most important ones are pandas, for organizing and cleaning data in structures called data frames, and NumPy, for performing complex mathematical operations. Python will supercharge your abilities, but finding insights is only half the battle. You also have to communicate them effectively. This is where data visualization comes in. You need to learn how to create charts and graphs that tell a clear story. Tools like Matplotlib and Seaborn in Python are great, but you should also explore powerful dashboarding tools like Tableau or Power BI. These allow you to create interactive visuals that let others explore the data for themselves. A good chart is worth 1,000 spreadsheets. And that brings us to the final, and perhaps most important, skill: data storytelling. It's not enough to just show someone a graph. You have to explain what it means. What's the context? What action should be taken based on this insight? The ability to weave a compelling narrative around your data is what separates a good analyst from a great one. It's how you get that manager to nod in agreement and say, "Wow, I never saw it that way before." Once you've built this core skill set, you can start thinking about specializing. Two of the most in-demand fields right now are data engineering and data science. Think of it like this. Data engineers are the architects. They build the pipelines and systems that move massive amounts of data from one place to another, making sure it's clean and ready for analysis. They build the infrastructure. Data scientists, on the other hand, are more like detectives or explorers. They take that prepared data, apply advanced statistical methods and machine learning algorithms to find deep patterns, make predictions about the future, and uncover insights that no one else can see. Both roles are absolutely crucial in the modern economy, and yes, they both tend to pay extremely well. Now for a pro tip that will put you ahead of the competition. Build a public portfolio. Don't just say you can analyze data, show it. There are tons of free public data sets out there on websites like Kaggle. Find one that genuinely interests you. Maybe it's about climate change, your favorite sports league, or trends in the financial markets. Analyze it, find some interesting insights, visualize your findings, and write up a short article about it. Publish your project on a blog, Medium, or even as a detailed post on LinkedIn. This does two amazing things. First, it gives you practical, hands-on experience. And second, it shows potential employers exactly how you think and approach problems. In the world of data, your mindset and your ability to reason are your greatest assets. As we look to the future, it's clear that technology is evolving faster than ever. Artificial intelligence might be the powerful engine that's changing our world, but always remember that data is the fuel that makes it run. The people who can understand data, shape it, and use it ethically and creatively will be the ones who aren't just along for the ride. They'll be the ones in the driver's seat, steering us toward the future. Every great piece of software tells a story. And that story isn't written in code, it's written in architecture. Every great piece of software tells a story. And that story isn't written in code, it's written in architecture. System design is what separates amateurs from engineers. It's the invisible logic that keeps apps alive when millions of people use them at once. In 2026, companies won't just ask, "Can you code?" They'll ask, "Can your system survive 1 million users at midnight?" Every architecture decision is a trade-off between speed and stability, cost and scale, innovation and risk. The best engineers know how to balance them. If you want to start mastering system design, here's your path. First, begin with the basics. Learn how web requests flow from a client to a server. Understand the journey a single click takes from a user's browser, through the internet, to your backend, and all the way back again. This is the foundation for everything. Second, study databases and indexing. Data is the lifeblood of any application. You need to understand how to store it, organize it, and most importantly, how to retrieve it efficiently. Poor database design can bring even the fastest servers to their knees. Think about how to structure your data so you can find what you need in milliseconds, not seconds. Third, dive into caching. Caching is your secret weapon for speed. By storing frequently accessed data in a fast, in-memory store like Redis or Memcached, you can dramatically reduce the load on your database and deliver information to users almost instantly. It's the difference between an app that feels snappy and one that feels sluggish. Fourth, understand load balancing. What happens when your app goes viral and traffic spikes? A single server can't handle it all. Load balancers are the traffic cops of the internet, distributing incoming requests across multiple servers. This not only prevents any single server from being overwhelmed, but also ensures your application stays available even if one server goes down. It's the key to high availability. Fifth, explore message queues. Not every task needs to happen immediately. For things like sending an email confirmation or processing a video upload, you can use message queues like Kafka or RabbitMQ. These systems allow different parts of your application to communicate asynchronously. Your user gets an instant response, while the heavy lifting happens quietly in the background. This makes your system more resilient and scalable. Finally, study microservices architecture. The old way was to build one giant application, a monolith. But as systems grow, monoliths become difficult to maintain and update. Microservices break down a large application into a collection of smaller independent services. Each service handles one specific job and can be developed, deployed, and scaled on its own. This approach gives teams more autonomy and allows the entire system to evolve faster. But here's the most important part. Don't just copy diagrams from the internet. Build something real. Create a small system that grows with you. Maybe a simple note-taking app. Start with one server, then figure out how to scale it to handle hundreds of users. Simulate traffic, see what breaks, and then fix it. That's how real learning happens. Not from books, but from breakdowns. True understanding comes from getting your hands dirty and solving real-world problems you've created for yourself. And a pro tip for you. Read the architecture case studies from companies like Netflix, Uber, and Amazon. They often publish their failures and redesigns publicly. These articles are gold for any developer who wants to think bigger. You get to see the real-world trade-offs made by the best engineers on the planet and learn from their multi-million-dollar mistakes without spending a dime. System design teaches you one thing no coding tutorial can: perspective. You stop thinking about individual files and functions, and you start thinking about flows and failures. You begin to see the bigger picture, anticipating problems before they happen and designing solutions that are built to last. Because when you can design systems that don't collapse under pressure, you're not just a developer anymore. You're the architect of something that lasts. And that's what companies pay for. Not just code, but confidence. The confidence that what you build today will still be running tomorrow, no matter what happens. 1. AI augmented productivity, working with the machine. Let's talk about the most important skill of them all, the one that's already changing how we work, learn, and even think. It's called AI augmented productivity. Now, this isn't just about using ChatGPT to write your emails a little bit faster. It's about fundamentally reprogramming your brain to work with machines as true partners. You see, a lot of people worry that AI is coming for their jobs. But that's not quite right. AI isn't coming for your job. It's coming for your routine. It's targeting the boring parts, the repetitive parts, the tasks that slow you down and drain your energy. And honestly, that's a gift. Because when AI takes over the repetitive, you're free to focus on the creative, the strategic, the uniquely human parts of your work. That's where we still shine the brightest. Here's an important insight to remember. Productivity in the near future, say by 2026, won't be measured by the hours you work. It'll be measured by the impact you create per hour, and AI is the ultimate multiplier for that impact. Think of it as a lever that lets you move mountains with a fraction of the effort. So, how can you start augmenting your own skills with AI right now, today? It's easier than you think. First, start using tools like ChatGPT, Claude, or Perplexity as your personal learning partners. Don't just ask them for facts. Ask them questions like you would a mentor. For example, explain this complex concept to me like I'm 5. Or, what are the counter-arguments to this idea? Treat it like a conversation, a real dialogue. Second, if you're a developer or even just dabbling in code, you absolutely have to try GitHub Copilot. It's incredible. Let it handle all the boilerplate code, the syntax, the stuff you've written 1,000 times before. This frees up your mental energy to focus on the high-level architecture, the logic, and the creative problem-solving. Third, for all the creatives out there, get familiar with image generation tools like Midjourney or Leonardo AI. They are not just for making cool pictures. Use them for rapid ideation, creating mood boards, or storyboarding a concept in minutes instead of hours. It's like having an entire art department at your fingertips, ready to visualize any idea you can imagine. Fourth, explore AI automation platforms. Tools like Zapier or Make are game changers for connecting all the different apps and workflows you use every day. You can build automated systems that handle tasks without you even touching your keyboard. Imagine a new lead comes in, and an AI automatically creates a profile, sends a welcome email, and schedules a follow-up task in your calendar. That's the power of automation. And fifth, perhaps the most crucial skill of all, learn prompt engineering. This is the art and science of asking AI the right questions to get the right answers. The quality of your output is directly tied to the quality of your input. Learning how to craft a precise, contextual, and well-defined prompt is the key to unlocking AI's full potential. Once you start integrating these practices, you'll quickly realize that AI is not a shortcut, it's a skill set. It's a new muscle you have to build. The more you understand how to effectively collaborate with it, the more you delegate to it, and the more you guide it, the more valuable you become in any field. Think about it. In the very near future, companies won't be hiring just developers, or marketers, or analysts. They'll be hiring AI-powered problem solvers. They'll be looking for people who can leverage these powerful tools to achieve outcomes that were previously impossible. And here is a pro tip for when you start working with AI. Don't just blindly accept its answers. Challenge them. Ask, why did you suggest that? Or, what are the alternatives? Push it. Refine your prompt. Rewrite it until the result feels like it's truly yours, infused with your unique perspective and expertise. That's the critical step. That's how you transform AI from a simple tool into a true teammate. It becomes an extension of your own mind. This is the real future of work. It's a beautiful dance, a collaboration between human creativity and machine computation. You bring the spark, the intuition, the vision. The AI brings the speed, the data, the execution, and together, you can build the impossible. We've covered the 7 skills that will define 2026. But here's the truth. It is not just about skills. It's about evolution. Every new framework, every tool, every trend is just a mirror of something older, the human desire to build better. So don't just learn React or Python or TensorFlow. Learn how to learn. Because when you know how to learn fast, you can ride any wave. Every era has its builders, the ones who see chaos and create clarity, the ones who look at the unknown and say, I'll figure it out. That's you. If you're starting now, here's your roadmap for the next 12 months. Step 1. Pick one core skill from this video. Just one. Maybe it's AI, or data, or cloud. Step 2. Learn the fundamentals deeply. Don't rush. Spend a month on the basics. Step 3. Build a real project and publish it online. Show your work. Step 4. Join communities. Get on GitHub, Reddit, and LinkedIn groups. Find people who push you forward. Step 5. Teach what you learn. Write about it. Post it. Share it. When you teach, you retain forever. By the end of the year, you won't just have knowledge. You'll have momentum. 2026 isn't coming to reward those who wait. It's coming to reward those who prepare. So prepare. Build. Fail. Repeat. And never stop learning. Because the future isn't about predicting what's coming. It's about creating what doesn't exist yet. Subscribe, share, and start building your future today.